Hi there, my name's Peter Harpending. I'm going to take this Khan Academy calculus thing and kind of walk you through my thought process solving each of the problems. And I might get some of them wrong. I haven't done this before. So I'm just going to do the quizzes. I'm not going to go through the lessons. And I'm just going to explain how I solve. Yep, let's go. Jesus Christ, can you stop? Stop. Just close all of this stupid shit. It's a reasonable limit for the limit. This is h as that there's no limit. So you can tell. So if they were approaching the same value, and it's not x approaches 4 from the right or the left, so sometimes this notation sucks, but this is the limit as x approaches 4 of h of x, and they approach different values from the right and the left, so there's no limit. Let's do check. Ooh, see, I've got the what are they called? I got the Skinner box reward. So it's like gambling. That's how I know I got the question right, because I got the good sound effect. The function f is defined over the real numbers. This table gives a few values of f. What's the reasonable approximation for the limit as x approaches 1 of f of x? Well, it's about 6 or minus 6. All right. Which graphs agree with this statement? The limit as x approaches 1 from the right of g of x is equal to 0. It's not that one. No. It's for 1? A 1 from the right. This one probably. B looks reasonable. Yeah, B. So this g of 1 is not 0 here, obviously. But yeah, that's the answer. These are really easy, so it's kind of hard to like reason through it because you can just look. The function f is defined over the real numbers. Okay, what's a reasonable estimate for x approaches 5? F is minus 5. Three from the left. X approaches 3 from the left. Minus 1 point. Okay, minus 1. Given the function g and asked to estimate limit as x approaches minus 1, 3 students created tables. Each table is accurate, but which one is best for approximating the limit? Okay, for Christ's sake, what kind of question is this? I would say this one. Just because, so my reasoning for this, so this one is only, answer B is only looking at the limit from one direction, and this one is looking too macroscopically. So a limit is a very microscopic concept. So I'm not going to get into like the full definition of a limit right now. There's a book called Principles of Mathematical Analysis by Walter Rudin, which is a great book if you want to get, here, I probably have it. Yeah. Yeah, here. This book, if you want to like really dig into what a limit is. The style, I like this style of book. So the thing about this book, so one thing that happens when you get into more advanced math, like beyond, I would say, so typically when you're an undergrad, your freshman year, you'll take calculus. And then your sophomore year, you might take a course on discrete math, which will be your first like proof course. And then you'll take a course on linear algebra. Beyond that, most math programs have a filter course. It's usually your junior year it's usually called Foundations of Analysis or Principles of Analysis. Analysis is rigorous calculus. So let's just do before I start talking. Analysis is just it's calculus, but it's more rigorous. And higher level math tends to be presented and when you read a book, it's presented in an order that makes logical sense. That doesn't necessarily match intuitive sense. So a lot of times when you're learning these concepts for the first time, like learning what a limit is, the definition of a limit is so weird, and it requires like this just giant mountain of background information in order to even like it's not that complicated, but like I'm making it sound more complicated than it is. But the point is that like here, he probably defines a limit. Let me just pull it up. Okay. Okay, like he doesn't even talk about a limit. So chapter 1 is the real and complex number systems. Chapter 2 is basic topology. Guys, basic topology. Oh, actually, do I have that book? I think I lent it to someone and never got it back. There's a book called Topology by James Munkres. That's a really good book for like learning. Hi, bud. Learning sort of basic math, like higher level math stuff. Okay, yeah. So we get to limits of functions in chapter 4. That's chapter 2 is basic topology. Chapter 3 is sequences. So the point is that concepts in sort of this is like the first math textbook you'll get if you're like a math major. This is the first like real serious math textbook that you ever have to grapple with. And what was I going to say? Things are presented in an order that makes logical sense, but that isn't really optimal if you're trying to expose people to the concepts for the first time and give people an intuition and a feel for them, which is what you're doing in like high school and your early years of college. So it's kind of tricky. Show summary. Okay, I don't need a lesson. I just want to skip to the next quiz. So let's go to the next quiz. Okay. Stop. I think I had an account and it got deleted. Function f and h are graphed. The limit as x. Okay, this stuff is so basic. Can we do stuff that's like... Oh, wait, I'm going to get up to 1 out of 4 skills. F and h. F plus h. Okay. As x approaches -3... But f doesn't have a limit at -3, so it doesn't exist? Because the limit from the left and the right would diverge. This is such a weird question. I don't like these questions. I think it's the limit doesn't exist, but this really feels like a trick question. Okay. F and G are graphed. F of G. Okay, but there's no... There's no limit. X approaches -1 of f over g. Oh, of h over f. But the limit... Oh. This is tricky. I would say infinity would be my guess, or it doesn't exist. My answer would be positive infinity, but of the answers here, I will go with that one. Because f goes to 0. So typically, when you have a limit, so limits, what's the word? Commute with continuous functions. So that's why limits are so important in calculus, is because they're sort of your avenue into the definite concept of a continuous function, and then into the concept of a differentiable function. And so let's check my answer before I start rambling again. Okay. I might need a calculator. The problem is that, so if you have the limit of a continuous function, you can sort of plug the I'm trying to figure out a good way to phrase this. The way that I think about it in my head is that if you have a function that's continuous at, x is equal to foo, then the limit as x approaches foo of the continuous function of f of x, so limit x approaches foo of f of x, where f is a continuous function, you can just sort of plug f of foo in there, and that'll be correct. When you have, the problem is that if you have, like, dividing x divided by y, f of x and y goes to x divided by y, that's a continuous function except at y is equal to 0. So that's the situation where you have a function that's continuous, but there's a discontinuity. That's the sort of thing that I am rusty on, because it's been years since I touched an analysis textbook or remembered this. I used to be familiar with all this stuff. The limit as x approaches 2, so the bottom part diverges of x plus 2. I would say the limit doesn't exist here because the bottom and the top are going to diverge. If you're in a projective space, then you could say it's the point at infinity. Cosine of x for x less than pi, and sine of x for x bigger than or equal to pi. The limit as x approaches pi from the right of h of x. The sine of pi is 0. So it should be 0, right? The only possibility that I'm wrong about this is if I forgot what sine of pi is, and if I'm just doing the geometry wrong. Okay. Limit as x approaches pi of cosine of x is going to be -1. Because like I said, cosine's a continuous function. You just plug pi in. Cosine of pi is -1. By the way, you remember cosine and sine. So a radian, which is the sort of natural unit of cosine and sine for angles. Angles aren't real, but forgetting about that, is the idea of a radian as compared to degrees. So what 45 degrees is, 90 degrees, 135. So the idea is that if you have a circle of radius 1, basically and then you take an angle, so let's say 90 degrees, the arc length of the circle of radius 1 of the subsection of the circle that is 90 degrees, that arc length is pi over 2, because given the radius of the circle r, the circumference of the circle is 2 pi times r. So 2 pi radians is all the way around the circle. So pi, if you start at 1, 0, and you go, I'm not going to try to do it backwards for the camera, but if you start at 1, 0, you're going to have to do the geometry in your head, draw a picture. If you start at 1, 0, oh, you know what, I could get my drawing pad out. If you start at 1, 0, or I could just draw on a notebook, and you go pi, well, pi is halfway to 2 pi, so that's at -1, 0. Cosine is going to be the x-coordinate, sine is going to be the y-coordinate. So, okay. Can I, like, skip ahead to a more difficult assessment? Okay, I'm just going to go to the unit test. Let's just try that. I love that it has a Microsoft Teams thing. F of x, the limit as x approaches infinity of f of x. So the answer is -6. The way that you can tell is that if you have the ratio of two polynomials, all you have to do is look at the biggest term. So basically, this is a concept in computer science. You might encounter it as the O of n crap. And the idea is that when you get to basically, the idea is that if you put like 700 billion in here, okay, you put a really, really, really big number in here, that the linear terms and the constant terms aren't going to matter at all. It's just going to be completely dominated by the ratio of the square terms, which is always going to be -6 to 1. If you had like an x cubed here at the top, the answer would be infinity or minus infinity. So the answer is -6. All right. Okay, let f be a continuous function on the closed interval 1, 5, where f of 1 is 1 and f of 5 is -3. Which of the following is guaranteed by the intermediate value theorem? It's a continuous function? Yes, okay. F of c is equal to 2 for at least, no. F of c is equal to -2, that looks plausible. It's this one, because this is just a stupid trick question. You just have to go read the question and the answer carefully. But basically, it's saying, here. Where's my drawing pad? It's in my backpack, which is in the other room. I'm too lazy to go get it. Oh, shit. Okay, I'm gonna go get my drawing pad, actually. Buddy, it's okay. Look at my drawing pad. I'm also gonna get another beer. Here we are. Do I have any actual liquor? Oh, I have some vodka. I don't need to drink. The beer that I'm getting is a 0% beer because I've been drinking too much and I'm getting too fat. For the kids out there, alcohol is, if you're watching this, probably you're about to go to college or you're thereabouts, and so, I don't know, you're about at the age where you're going to start being exposed to alcohol and going to start having access to alcohol. So I'm going to give you some non-BS information about alcohol. Alcohol is a wonderful, wonderful, wonderful social drug. There is a reason it is a universal drug. However, there is a subset of people, and you may or may not be in this subset, and there's a subset of people who are genetically predisposed to be extraordinarily addicted to alcohol, where it will just completely ruin your life. And where, all I'll just say about drugs in general is be very, very careful about the demons that you choose to let into your life. Once you let a demon into your life, you never really get it out. You just have to manage it. So, things like opioids, like heroin, don't ever let that demon into your life. That will just permanently screw up your life forever, and you will never get it out. Alcohol, alcohol is one of those drugs where, if you don't drink, you're probably gay. And if you do drink, it might ruin your life. But alcohol isn't good for you. And, I'm one of these people who, I don't have a serious problem with alcohol. Never have had a serious problem with alcohol. Some people get, just way too drunk. But I like it a little too much. if you're like Native American, probably you have a genetic predisposition to alcoholism, and if you are going to drink, do not get behind the wheel of a car ever. Should not need to tell people that. That's another thing. Like, if you are going to drink, you need to think about these things ahead of time. So, like, I'm going to go out drinking. I need to, don't put yourself in a position where you are going to be intoxicated and also need to drive your car. Like, think through these things ahead of time. Make sure that you can afford an Uber. Ubers are a pain in the ass. I get it, but Anyway, find the limits of h at positive and negative infinity. So the limit as we go to negative infinity is 2. 2 and limit is minus 2. All right. F and G are graphed. F, oh, for Christ's sake, F plus G as we go to 1. So F goes to 3 and G goes to 1. So that would suggest from the right, or from the left, we go to 4. And then from the right, this is such a tedious 1 and 3. Okay, so it's the same in both directions, so it's 4. Unless I'm getting tricked. This is one of these questions where you have to look at the question really carefully, and the only reason you're going to get it wrong is if you're sloppy about that. Another thing about alcohol, if you have if you're fat, like me, if you have, problem with eating too much, alcohol is going to make that a lot worse because when you get, number one, alcohol itself is going to make you hungry. Number two, alcohol, if you're trying to diet, alcohol reduces your inhibitions, which is why it's such a great social drug, but it's also going to make you stop caring about things and stop caring about, being proper and sticking to my diet and all of that shit. So if you're trying to diet, me, I've gotten too fat, trying to lose some weight, alcohol is just the worst fucking thing you can do. Anyway, Elena's teacher gave her a flow chart and asked her to find limit as x approaches minus 8 of g of x for g of x is equal to x squared. What the fuck is this? What is this fucking flowchart? Drag the cards below? What the fuck is this? Okay, here's what, okay, fuck all this flowchart shit. Okay, let me tell you how you actually do this. You look at the denominator of the function, you say, is there a discontinuity or a 0 at minus 8? Well, gee, this looks like it's discontinuous at minus 8. Okay, so let me show you how you actually do this, okay? So this is my actual thought. This is a perfect example of why I actually wanted to do this video, okay? So 22, 25, I don't know how far we are into the video. This is a perfect example. Okay, so the actual process is you look at the denominator. I'm gonna brush. This is one of the most frustrating programs in the world. I just want the plain brush. Let's try marker fat. Okay. So what you do is you look at the denominator of the function and you say, is it 0 at minus 8? This certainly looks like it's 0 at minus 8. So that... Okay, I'm just going to get calculator. F is equal to... I think that's the syntax. Okay. Then f of minus 8 Yeah, so this is 0. So what you then would do in the real world, this is something you'll learn in calculus, is called L'Hopital's rule. And what you do is you differentiate the top and bottom of the fraction. So specifically what it says is that you would take the limit as x approaches, I'm just going to say foo, of f of x divided by g of x. If they're both differentiable, this is the same as the limit as x approaches foo, if they're both differentiable at x is equal to foo, of f prime of x over g prime of x. So the actual answer is you use L'Hopital's rule. So fuck all of this. Is this just asking if I'm going... This is just asking me to turn this flowchart into... This is so fucking stupid. Fuck all that flowchart shit. Okay, the actual answer is you use L'Hopital's rule. So the actual derivative here, 3x squared plus 24x, the derivative of this is going to be 6x plus 24. X squared plus 16x plus 64. This is going to be 2x plus 16. Okay, then we take the, what is it, limit as x approaches minus 8 of 6x plus 24 divided by 2x plus 16. This is going to be, you just plug it in. You just plug it in, whatever that is. Oh, actually, it's 0 on the bottom. That's crazy. I didn't notice that. Yeah, it's also 0 on the bottom. Yeah, so you're going to have to do L'Hopital's rule again. So that's the limit as x approaches minus 8 of 6 divided by 2. The answer is 3. Okay. Which, actually, that kind of makes sense. Yeah, interesting. Okay. Yeah. So basically, but that's the actual way that you do it. Okay, so drag the cards below. I'm going to fuck this up. So A, we do direct substitution, and we get B divided by 0. Okay. Oh, wait. Let's just call it yeah, actually it's going to be a 0 over 0. So actually it's going to be an how do I get rid of this one? No. It's going to be an indeterminate form. So then what the hell are conjugates? I don't know, factor it maybe? I don't really remember how to factor polynomials. So this would be x times 3x plus 24. I don't remember how to factor polynomials. It's like the completing the square shit. I don't remember any of that. What the hell are conjugates? I'm just going to guess factoring. And then I'm just going to guess conjugates. I don't know what conjugates are. And I mean, I know what a conjugate is in general. I'm going to get this wrong. No. All right. Let's try swapping factoring and conjugates. Oh, wait. Nope. Okay, let's try indeterminate form. Okay, let's try show a step. Yeah, I got that. Oh, right, 3x times x plus 8. Okay, right, you could do that. Okay, that makes sense. See, I was just too lazy. Right, okay. The limit... Huh? Okay. I apparently am... Oh, I'm so stupid. Okay, perfect example. Perfect example. So, the issue is that L'Hopital's rule only applies when the limit is 0 over 0. I'm stupid. Okay. See, this is exactly the sort of thing I need to review because I just forgot. I just remembered L'Hopital's rule, and I forgot that really, really important caveat of L'Hopital's rule. Okay. So, doesn't exist. Okay, perfect. Okay, so we do factoring. So we tried direct substitution. Then we go with we got an indeterminate form. Then we factor it. Okay, and then we got... What did we get? Okay, we do direct substitution again. And then we got we didn't get an indeterminate form. We got an asymptote. Okay. That flowchart's fucking stupid. But I understand why they're doing... Okay, the limit as x approaches positive infinity. I don't know. I would guess 3. Because you got a square root of a square function, so this is going to be roughly 1 in the bottom. So I'm just going to guess 3. Yeah. G of x. Okay. G is continuous. Oh, I see. So it's like you have a discontinuous function that has a whole... Okay. So this is another way of asking what is the limit, is another way of saying. It's like, say you have a continuous function that has this property except at 0. So basically it's asking what the limit is. So it is 10x... I mean, I just kind of want to graph this function. Oh, we can just cancel x out of the bottom. And you would get 10 divided by x squared plus 5. Squared plus 5. 10... divided by 5, that's going to be 2, right? Okay. Which functions are continuous over the interval 0, 5? Not that one. Not that one. Both of these are discontinuous. X approaches -7 from the right of h of x. I don't know. This function's diverging really, really quickly. I would guess negative infinity. Has an asymptote. Okay. God, I understand why people hate math. This shit's boring. And just tedious. Math actually is a really fun and interesting and cool subject. There's a channel on YouTube by a guy named Norman Wildberger. If you want to see like the cool math that's like fun and actually interesting, or my channel, I do fun and interesting math. Then, you know, that's where to go. All right. The limit as x approaches 2 from the left is on, yep, that's true. The limit as x approaches -4 from the right is 2. That looks reasonable, I'll say yeah. The limit as x approaches 2 from the right is unbounded. Yeah, I would agree. And should I also select none of the above? Find the limit as x approaches -2. I actually don't know how to do this. So my impulse is to multiply the top and bottom by something that clears the square root. This is probably that conjugates thing. So the problem is we have a 0 here in the bottom. So we need to do something to get rid of the 0. Or wait, do we have a 0 over 0? That's actually a better question. So minus the square root of 6 times -2, which is 12, minus 12 plus 21. Minus 12 plus 21. That's 9. The square root of 9. Okay, so we do have a 0 over 0. So real world, I'm going to use L'Hopital's rule. And I'm going to get... Actually, okay, this is maybe a good example of L'Hopital's rule. So, limit as x approaches -2 of 3 minus the square root, and I'm going to actually write this in calculus-friendly format, 6x plus 21 to the 1/2 power divided by x plus 2. Oh, shit, no, we're going to get... We're going to get an infinite fraction issue, aren't we? Let's just try it. So this is get... That's just going to disappear. It's going to be minus 1/2 times 6x plus 21 to the minus 1 half times 6 divided by the derivative of the bottom is 1. So if we do all of this, it's going to be the limit as x approaches minus 2 of, just going to do some multiplication, minus 6 over 2, it's going to be minus 3 times, going to be minus 3 over a square root. But then I feel like we could multiply it by the square roots again to get a square. There's an algebra trick. I'm sure there's an algebra trick to do this. You know, okay. At this point, the correct thing to do is to just graph it. Do I have a graphing tool? I guess I have GeoGebra. So this is going to be, I'm just going to write limit sub 2. Oh, it's minus 2 of minus 3 divided by the square root of 6x plus 21. It's an actual time you use L'Hopital's theorem. Then if I multiply the top and bottom by the square root, this is going to be minus 3 square root of 6x plus 21 divided by 6x plus 21. That was a terrible. And I'm supposed to be doing this x goes to minus 2. Don't you love my super consistent notation? And this will be minus 3 times the square root of 9 divided by 9, which is equal to minus 1. Let's try this. L'Hopital's rule. I hate this. This is so tedious. How many questions do we have left? 12 out of 31. Jesus Christ. Okay. Okay. Which limit expressions agree with the graph? Oh, my hard work paid off. How much time? How long have I been going? 45 minutes. Okay. I'll do maybe 1 or 2 more questions, and then I'm going to take a break. Which limit expressions agree with the graph? No. X approaches 0 from the right. So it had, okay, that one's true. 4 from the right is minus infinity. I think that's it. Okay, if we get another tedious question, then I'm gonna just go until I get another tedious question, then I'm gonna take a break. Well, the function f over the real numbers 2.8 I mean, I would say 2, okay, sure. Minus 3 G times F, I would say 0. Because here you don't have a denominator issue, and it doesn't matter because it's like finite times 0, so it's going to go to 0. X values at which G has a jump discontinuity? The fuck is a jump discontinuity? Oh, I think it's a non-asymptote discontinuity. I think that's what they mean. I would say none of the above. Unless I don't know what a jump discontinuity is. At x equals 3. Yeah, both limits exist. No, the function doesn't have... So it has a limit from the right and a limit from the left, but it doesn't have... The limits are different, so... Yes, g is defined. It is not continuous. Okay. F is defined. X approaches 4. There is no limit. The natural logarithm, neither of those are continuous. Neither of those are continuous for all real numbers. The squeeze... Oh, fuck, I used to know that. Why do they have to make it into a fucking story? Like Leona. Who the fuck is Leona? I used to know the Oh, right. Squeeze theorem. I would think the squeeze theorem, if I just had to guess, I don't remember exactly what the squeeze theorem is. I knew what it was at some point. I would guess that if you had a function where you could bound f above by one of these and bound f below by another one, and both of those had the same limit, then you could basically say, okay, the limit. So let's say that h was like strictly bigger than f, or bigger than or equal to f, and g was smaller than or equal to f. Both of those are continuous functions, let's say, and they agree in terms of their limit at that value, or they agree at that value. And so you say, okay, well, we know that the limit of f has to be less than h of 0. So the limit of f as x approaches 0 is less than or equal to h of 0. And we know we can bound it above by h and we can bound it below by g. And so if those agree, then we know, then we can pin down exactly what f's limit as x approaches 0 is. Yeah, that one. Leona's suggestion is incorrect because she's a stupid bitch. Yeah, that one. Okay, this looks like a tedious one, so this is probably where I'm going to stop for now. Oh, it's just plugging the values in. So 7 plus minus 3, so that's 2. Minus 3 squared is 9. Minus 5, no. Limit as x approaches 4. Is 12 divided by 2 times 6, so it's 1. Huh? Okay, so f of 0 minus 1. That's just one where you have to stare at the problem for a while. Oh, for fuck's sake. What is this? It's minus 1 over x, so it's going to go up and down. Okay. From the left, it's going to go up. No. Wait. This is so confusing. So from the right, no, from the right it's going to go down. From the left, it's going to go up. Yeah. This is a classic example of L'Hopital's rule, I would say. So you do cosine. It's going to be 1/2. Pythagorean identity. Okay, I don't know. I used L'Hopital's rule. F is continuous. Has a solution. Ilo's I'm just going to guess B. This isn't a very good question. This is a really poorly written question. Next level. Okay. 1 minus x. I actually don't know. The cosine's just going to oscillate. So it's going to be linearly decreasing, but it's going to oscillate. Yeah, that limit. There's no way that limit exists because it's it's like it's 1 over a trig function, so it's just going to have a shitload of asymptotes. It's just going to be like, I'm guessing? No. Oh, God. No. I meant the limit doesn't. Okay, I just misclicked. I'm stupid. Okay, one of them, so I've gotten two of them wrong. One was because I was too lazy to actually do the problem, or because I didn't know L'Hopital's rule correctly, and one of them because I misclicked. Okay. Tangent is sine divided by cosine, so it's going to be 0 divided by 1. Hi, buddy. Come here. You all right? Um, e to the 4th. Oh, wait, no. E to the 0. It's going to be 1. And 0 to the e. I'm just going to guess no, because that just doesn't seem like a continuous function. Okay. Oh, I see. Not constant. It wants them to be like to zoom in and to not have, I don't know what the term is, to be non-constant. All right, last question. Okay, we got through it. Okay, the limit as x approaches -4. I said I was going to quit at the next tedious one, but we're almost done. So this is x plus 4 times, wait, no. Yeah, this is going to be x plus 4 times x minus 4 in the top. And this is going to be x plus 4 times x in the bottom. So you can cancel the x plus 4s. So it's going to be x minus 4 divided by x. So it's going to be 0, I think. No. So it's x plus 4 times x minus 4 in the top, right? It's a difference of squares. And this is going to be x times x plus 4. Oh, so it's going to be x minus 4 divided by x. So it's going to be minus 8. Oh, geez, it's 2. I'm just bad at doing math. So again, I got one wrong because I'm being too lazy, and my hands are occupied, so I can't use the drawing pad. All right. All right. I think that's a good video. Is probably a little too long, but I'm gonna take a break. I think the next video I'm gonna try to do, like, instead of just a section, like instead of just limits, I'm gonna just try to do like all of calculus, because that's too many questions about limits.